Hello, my name is John Richter. I'm one of the instructors here at Financial Mechanics. Welcome to this video on timing flags, which I've proposed here is perhaps the most important component in fast modeling. And I think it deserves a very sort of basic and core review, which is what I'm going to attempt to do over the next 10 minutes or so. First off, what is a flag? And at a technical level, it's a very simple definition. A flag is any series line item that contains only zeros and ones, and that's quite crucial. If you've got anything else in the line as far as numbers, don't use the word flag. It's one of the most universally recognized words in modeling that consistently means that digital concept of 0 or 1. If you've got something that is ranging between 0 and 1, and we can talk about situations that might give rise to that, use a different word like factor or something that doesn't indicate that you think something is digital, on or off. Flags have three basic forms when you look at them. The simplest is a single point in time situation or a single period in time, but ultimately where the flag has got a single one in it. You have situations where you need to range values over a stretch of time, a period of time. So you have period type flags. And finally, you use flags in circumstances where you have periodicity problems, situations where some value recurs on some pattern. The pattern, of course, indeterminate, but the ones come in place on that periodicity. Next sort of point I suppose to sort of make or ask is, what problems do flags solve? And I think for that we need to kind of take a look at a simple example and see what happens without flags. So here we are with a fairly blank sheet called pool. And as you can tell, what I'm going to get up to here is to avoid being distracted by any financial complexity and deal with a very basic picture of filling up a swimming pool, something I think we can all get to grips with, and you guys don't have to accuse me of being just a project finance guy. And from that position, you can see we have a daily date header, and I'm going to propose that we have a situation where we have a filling rate of some, 2,000 gallons per day on those days in which we actually do fill up the swimming pool. So you can see I'm just sort of sketching out a problem. And I'm going to say we have a first filling date of 6 July 2010. Okay, you can tell that's a nice good looking integer which we can date format, and we'll say that's a date. And what you might do with this sort of how much and when question, at least on the first filling date, is to simply say that your line item here for water added, I suppose, to pool, I won't say deposited, would be something where, a lot of modelers would just go, well, if this sort of header date here is equal to that date, then we'll go ahead and put in 2,000 gallons, otherwise 0. And we could copy that across, see the 2,000 pop up in the right place, kind of press on with our problem. The difficulty then becomes, a situation where you got a second filling date. And on the second filling date might be, I'm going to say 7 July. So I can see it all on this fairly high magnification screen. And you'd come back in here as the modeler and do some sort of incrementally complex kind of horror with maybe an or if the date, I guess I've got to go up here to the date line again, is equal to that next, I guess I put this in front, so this is all around going to be an awful formula, but that's fine. It's kind of my intent here to create something that you guys are going to say is getting worse and worse as we go. And there the 2,000 comes in a couple days, and you can start to see that our formula is getting very non-fast compliant very quickly, tricky. I'm editing a pre-existing formula and all that kind of thing. And this situation is not good. And ultimately, in answer to our question, what you'll find is that flags are the source of solving these if function horrors 90% of the time. So when you find yourself with something that you kind of shaking your head as some, I don't know, combination either of nested ifs or logic and or functions inside of if statements, inevitably with that otherwise zero construct on them, you are automatically telling yourself this modeler should be using a flag. And that's where we pick up with kind of the question, well, how do we use them? What am I talking about here? I got the plot, John, about this zeros and ones, but I can't say I quite follow you yet. And that's what we're going to hit next. So here we are back on our pool sheet. And what we're going to do is an alternative approach where, yes, we have the filling rate. Of course, a mislocated input. You guys will tell me I really should square bracket that and get it moved to the input sheet later. And what we're going to do is use another placeholder for what we will call filling day flag. So anytime you've got a day where you are filling the pool, when the maintenance guy shows up, you have a flag, and this is a good opportunity for a placeholder. And what you know from your assumptions is that filling occurs on those 2 days, and the water added to the pool, I'll save myself some typing, get that labeled down here, is simply A times B. And you've got to like A times B as a fast compliant formula that gets the job done. And this is using a flag. Now you guys are going to say, well, hang on a minute, John, there's got to be some logic complexity behind calculating these two ones from these input dates. And you're absolutely right. The purpose, though, of this particular video is just to ensure that everybody is comfortable with the simplicity of flags. The power of the flags is a placeholder component, perhaps, and perhaps even isolating your flags on a different worksheet. So what you might sort of say is we should put this filling day flag onto our regular timesheet, which might have some leftover flags from other model instances, possibly even take that hacked line, paste link it for now, and worry about actively calculating this flag is a second exercise. That would be an import, of course, from these 2 dates. So we'll go back to our timesheet, throw those 2 dates in there, and we could kind of consider, well, how might we do this flag calculation? And we might ultimately end up with something that is similar in complexity to what we saw before, but crucially, the commercial calculation of the pool filling was left denuded of that complexity, that we are isolating the complexity of time just in the calculation of the timesheet. And setting up the flags and getting them to work properly, I will leave to another video. What I wanted to do for this video was simply demonstrate the use of the flag, which I hope you guys see that we've accomplished here with that simple A times B. If you were to modify this model and simply say that you have a different pattern of filling days, even with this placeholder, you could simply punch in these ones in a different place and shift F9 or refresh the model, and you'll see that the filling days pop up accordingly. So that was a quick demonstration of how we might use a flag, and by that example I hope we give you kind of a sense of what we're talking about. And just to finish up, I guess I'd like to try to talk through the sort of main points I wanted you guys to take away from this. First off, if you've got any question of time, use a flag. Classically, as a modeler, as we teach routinely on our courses, you've always got the how much. In this case, it was the 2,000 gallons per day that gets filled. But there's always this question of when. It's almost what defines a model, is this concept of time. Use basic multiplication by default. Be extremely wary of using this if the flag is equal to 1, take the value, otherwise 0. You guys might ask yourself the technical question of how and why that is different from X times flag, and I will leave that for another video. It will emerge on the list and you guys can ponder that one in your spare time. The design concept that we've talked about can be extended to the analog, as I've said here. Wondering if that's British spelling or not. It shows you a bit too much time in Britain, perhaps, for yours truly. But in any event, the concept of an analog flag is often referred to as a partial period factor. And you guys will say analog flag is an oxymoron, John, because you told us flags had to be 0s or 1s. So I really mean an analog timing component is a partial period factor. And that, again, we can pick up that slightly more complicated use on a subsequent video. And finally, I guess I do think that a flag is potentially fast modeling's most important component. And no, financial mechanics did not invent flags. I was introduced to flags even prior to the company I worked for even using spreadsheets, so it dates me a little bit, but I got out of business school in 1992, and in our financial modeling packages, one of the guys there, or it was passed down through the generations, God knows, said you got to use flags for this kind of thing. You got to get away from that if function sort of stuff. And that's where it came from. Been around for a long time. We don't claim to invent it, but it's an important component, certainly, of the fast modeling standard and installed in everything that we build and everything we teach. And ultimately, when you think and ask most experienced modelers, the most important, most complicated probably component of what they need to solve are problems associated with time. And flags, as we sort of showed, were a good way to break out the complexity of those time calculations and keep your commercial calculations free from that complexity, keeping your formulas simple and easy to read. And with that, I will say goodbye for today. I hope you guys found that a useful introduction to timing flags, and there will be plenty more on this topic going forward. So look out for future videos. Bye for now.